reason why triplets are really beneficial is then you're alternating hands. So you're on a drum set. You go right, left, right, left, right, left, right, left, right. Ah, look at the drumsticks as soon as we said it. All right, so I got a question for you. Because why would you come to math and I not have questions for you? So right here, and I don't know if it's ever going to focus, is a stack of pennies. So I have these taped together from a Math 7 activity. Man, it keeps focusing on all this stuff. Jake, will you throw my door shut? All right, so question for you. Talk with your group. How long or how tall, however you want to talk about this, do you think 10 to the 15th, all right, this isn't working. So we have these pennies. There are, I think, 14 pennies here. So more than 10. But how far do you think 10 to the 15th power? And now I have my boards. My board over here has just taken to being the Math 8 board. And the board over there is taken to being the Math 7 board. So I have more Math 7 students than you guys. So sorry, when you walk in, your attention is that way. Which I like because Math 7 will eventually get to that stuff. But then during class for Math 7, I can reference that whiteboard. But so we're talking about exponents and scientific notation. And scientific notation has to use exponents. Come on, make things easier, not harder.
I think we like X, Y stuff.
You with me now? Yes. Okay. So, take like 30 seconds. Talk to your team to make an estimate of how far 10 to the 15th power pennies would reach.
How much is that?
I don't know, like an inch or so.
Oh, how many pennies is that?
Yeah, if I stacked up 10 to the 15th.
No, how many pennies do you have right now?
This is 17. I can get out individually. It's just annoying if I try to hold them individually. But like if we stacked up, because lots of people do like art and stuff with pennies because they're cheap, right? They're a penny.
Yeah, no, pennies cost a penny.
Actually, back when we used real copper, they cost more than a penny to make a penny. Annie, you want to make a guess? Well, I don't. That's not even what we're asking. We're just asking like how max. What? Okay, but how big is that? Connor? A 1,000 Brendas. Brenda's pretty tall. Like Brenda's pretty tall. Jake?
So find out how what the number is, and you can use the measurement of pennies.
Jake's trying to be all mathy about it. I think Max is about to try to steal these from me.
I need to borrow them, please.
So,
I need
one.
to borrow them compared to
No,
what Brenda
because then we got to move on. No, I want you to be like hungry to solve the math, but I don't want to let you do it right now. So one of my favorite web pages is a page called They Did the Math, which actually then people can put requests on. And my question is this meme correct? And I don't know, we would have to do some math to figure it out. But as I was looking at like scientific notation stuff online, of course when I saw this, I was like, wait, is that true?
No, it's not.
And we can mathematically solve if this is true. So if we have time at the end of class, we will dig into trying to figure out, is this meme true or is it another internet malarkey where somebody just put something for clickbait and it's not actually mathematically true? Brenda?
How are we stacking the pennies? Like this?
Stacked.
Or like
At least when they say stacked on top of each other, I assume flat stacked, but I guess we could solve it both ways, right? Like we could do the problem both different ways since it doesn't specifically say. All right, so real quick on graph paper, we're gonna solve a few problems just like speed round.
Homework. This is on our homework.
83 was on your homework? Because I think this is a lesson problem.
It's on the first page.
Oh yeah, so if you're like Anna, you may have already done this. But we wanted to circle back to renaming. Did anyone think up any better names for the giant one? I've heard bonfire fraction
Yes.
is what people want to say. Spencer? Big Daddy Uno. I like that a lot. Patrick. Sorry, Connor. You're both wearing beanies and the top 2 inches of your face look similar.
And also the
Connor.
I was gonna say keep it Spanish. It's Gordo Uno, which is fat one.
Gordo Uno. Ooh, since we start learning Spanish in middle school, that might be really good. Gordo Uno.
Gordo. I still like the bonfire fraction.
Bonfire fraction. All right, so
Big Daddy Uno. That's awesome.
to review why we were using the Grande Uno. Ooh, if I call it that, I can roll my R. To review our Grande Uno application, you have 30 seconds to simplify all 3 of these. Grande, bonfire, big day. It's the longest name ever for a thing that just means one. Connor? What, is it on your paper? I mean, you could hold it. Oh, I was gonna do this while you were while I was passing out papers. Oh, we should probably check homework too. So we'll do that in a second. Yeah, do this to warm up, and then we'll check 823 and turn it in. Get me hyped, yeah, because you've had it since last week. We're not gonna check it today, though. This problem is on the front of 823, as Jake told you. You don't have to copy the whole thing down. It's on the front of 823. You can solve it right there on 823. So what is it? Well, you already did it. Yeah. Yeah, because a 6 over top of a 6. Alright, y'all seem like you're moving on from this real quick. Try this then too. Try that, but write it without the fraction bar. Try this, but write it without the fraction bar. I may have forgotten to put a check on it, but let me verify that I put it in the grade book. Hey, did you guys solve these? Or you just like are so confident? You're like, oh, I can look at that and solve it.
Oh, I wrote it down.
Jake, back to the one that was on your other paper. What is A when simplified? It's what? It's what?
6 squared.
I thought you were saying 63, and I was very concerned that you were like
6
having a
squared
mental
or
issue.
36.
So 6 squared or 36. Walter, what about B? What would that reduce, simplify down to? W to the what power? Yeah, to the third power. We don't know what W is, so we can just leave it like that. Aiden, what about C?
10 to the first.
Yeah, just 10. Over here, you guys are starting to like show off. Maddie, what about A? How do I write that? Avoiding using the fraction bar. Like, I just want to say 6 to a power. What would it be? Yeah, absolutely. Jordan. The what is your card came up. There's a question for you. A. You're looking at A. How do we write it without a fraction? Just 6 to a power. Huh? Is it what? Amelia. Close. Negative second. So guys, be careful because this is where we want to review. If you end up with repeated multiplication, but it's in the denominator, that's really repeated division, which is where exponents and scientific notation, if the power is negative, like I have over on the board in the red squiggly box down there, when the power is negative, it's representing repeated division, or you could also say repeated multiplication in the denominator, but that seems a bit more complicated. Jordan, you want to do B now?
Well, I said divide.
You said what?
Divide.
Oh, but we're trying, like, do you understand what I was getting at, what we were trying to get to? So you're right. Do you want to do B or do you want me to move on? You'll do B? Okay. It's just, careful, it's just
M to the negative first power.
M to the negative first, which is not the same as negative M. So, I like that you're making a face because that tells me we need to re-explain this. Hey, those of you not listening, thank you. So, I appreciate that Jordan took the risk to say the answer he thought and then made a sour face when I told him, not quite right. So, this would have 5 M's that are canceling out and making Gordo Unos. However, we'd end up with 1 over M. And if you just have a value in the denominator, but you don't want to use the fraction bar, this becomes M to the negative first, saying whatever happens, whatever other number you have, we have an M that needs to go down to the denominator or act as division. Does that make sense? A little bit, at least? I'm talking to you, Jordan. Does that make sense? I can't tell from your bounce. Does that make a little sense? Okay. Connor, what about C?
The answer?
Yeah, the simplified answer.
Oh. 10 to the negative third?
Yeah. It's like 10 to the negative cube? And here, this was on your paper. We've done this a couple times, so we're going to keep rolling.
We do homework.
No, because I have a whole lesson after this to get to. We're going to skip this, we're going to skip this, we're going to go there. Oh yeah, let's check 823 now that we're finally done with 823's lesson. Because then you can turn it in, now that we're finally actually done with 823. 823. She still lives in Coshocton. Oh, thanks. Questions. Max, was this the homework that I had like a typo? Yeah, so 889 didn't. Or it was Jake or somebody.
I did.
Yeah. Hey, so the like 5 of you that are talking at the same time as me, you are making my job more difficult. And I do not really appreciate that. Let's be on the same team, please. We are on the same team. 889, I forgot to include the table. I don't know if that was a print issue or a me issue, but you can essentially just skip it. We've looked at tables like this, and if you want to see a really impressive table like this, I put an example over here by the scientific notation area, all the way from yada. Yada is a 1 with 24 zeros after it.
Septillion.
It is septillion. But the prefix of it is a yada. Which, there's an old show called Seinfeld where this person says yada yada over the middle of the story, and it always makes me laugh about that. Because they skip all the important details. All the way down to a yocto. Sounds like a Star Wars something. A yocto is 1 divided by a septillion, or 10 to the negative 24th, which we call a septillionth, which just sounds like a month of the year, honestly, to me.
It kind of does.
September.
All right, so 89. Any questions on 88? Any questions on 88? Please stop saying September. I'll break into song by Earth, Wind, and Fire.
Wait, what?
You don't know the song September?
No.
Any questions? 90, 91, 92, 93. We got more to check. We might not have every question on here. 93. You've forgotten the Chubby Bunny Kitty? You want to explain what to do, Jordan? I'm going to put it up on the screen, but I was about to say, I guarantee we get somebody to volunteer. No, Jordan already said he'd do it. All right, so 93. Hey guys, I don't want to make a seating chart or get strict again, but we're having a big issue in this class of people talking when it's not appropriate, so I need you to fix it so I don't have to fix it. Every single one of us should be checking our answers right now, and every single one of us should be modifying or asking questions on things that we got wrong. If you're not doing that, you need to adjust your calibration of what is appropriate during class. We've gotten a bit too lax, and we're deep in the school year. I should be able to loosen things up with you guys because you know what's expected and you should just do it. But if you're making things more difficult, just leave. I don't know what to tell you. If you can't handle yourself, go away. Or fix it. But if you can't fix it, I don't know. We don't need you in here making things more difficult. Love you, but act how you're supposed to act. Or go put yourself in timeout. The Chubby Bunny Kitty method to determine our point of intersection is where, since both of these are equal to the same thing, they both equal y, we would take them and set them equal to each other and use algebra and inverse operations to put my x's together, put my constants together, and then solve from there. So remember, Chubby Bunny Kitty method, which I'm looking for a nice, clever, I think I like grande because I get to roll my R. But yeah, instead of giant one, the grande uno. All right, refocus. Refocus. Any other questions up through 93? Because we got more to check than just that. Any other questions up through 93?
Yes, there's
Max.
895C.
That's not up through 93. That's past 93. So let's scroll to those answers. You said 95C? Well. 95C, and we'll bump back there in a second. This is already dividing by 4 3 times. Because this, when expanded, would be 1 cubed over 4 cubed, or 1 over 4 times 4 times 4. Then, times 4 times 4, if we want to make it a fraction, we'd say over 1, because 4 squared is 4 times itself. When we put these together, we will have 4 times 4 on top, and 4 times 4 times 4 on bottom. We get 2 grande unos, and we end up with 1 over 4. Or you could say 4 to the negative 1. Back to the key. You mean move the stuff up so you can see more? Notice how I was begging for any other questions about 893. So -2, -7, 1/2, -4. All right. So 94, 95, 96, 97. Scrolling on down. All right, well. 94, any issues fixing those numbers and getting them back into scientific notation where that first number has one digit in front of the decimal?
Possibly. Not. Hopefully.
Oh, I gotta do D.
Let's go.
Uh,
You gotta do D on paper.
See, now I'm starting to get nervous that you guys will just do that to mess with me and make me say do D, but okay. So, if I look at how to do D,
You are really bad at D.
remember a power outside applies to everything inside. So this is really x cubed y cubed over x y cubed. So when we make a grande uno right here, and then we make one grande uno with the x's, we still have x squared left over. Does that make sense how we end up with x squared as our answer? Does that make more sense? So if we write it out expanded, these y's are a bit more obvious that they would cancel out, but if I look at just the x part,
That's not a campfire.
triple X, that was a movie from back in the 2000s. So right here, that becomes 1. So we have x squared left on top. Lily? B. Yo. Careful saying that. You might get yourself in trouble. So,
Could I please have Anna Stewart to the office? Anna, please come to the main office. Thank you so much.
where'd my Post-its go? Huh. Guys, if you're just talking, go somewhere else. Seriously. If your conversation is more important than us doing math, bye. Go to the family room, go to somebody else's classroom, go to the office, tell Mr. Flynn what you got to say. But I'm over it. We have math to do. I have a lesson to teach, and I only have 16 minutes left, and we're still checking homework. You're wasting time. Stop it. Your conversation is not more important than your classmates' struggles. So either, and I say this with love, either shut up or go somewhere else. I'm serious. People are asking questions on math. I don't care if you know what you're doing. Not everyone in here does. This is saying that 10 is going to divide twice and x is going to divide twice. So if I rewrite this, I have 10 x to the fourth on top, and what is being divided is 10 times 10, because there's 2 of them, and x times x, which we could just write x squared, but I'm going to go ahead and write x times x. We know x to the fourth is actually, I'm just going to scribble that out, x times x times x times x. So one of the 10s becomes a grande uno, and 2 of these x's become grande unos. So then on top, we have x squared still, and on bottom, we have 10. Does that make sense now to anyone that was confused by that? Back to the key. And what's killing me is I walk around the room and people aren't done. So if your homework isn't done, zip it and work on your homework right now. Do not say, "Oh, my homework's not done, I'll do it later." Hey, you want to go to the movies tonight? You want to, like, why are you talking when you could have time to work on your homework? I just don't get it. And guys, you got to realize your teachers, well, some of us will go home and Zoom from home. We're trying to recruit the next class of Phoenix people. I don't know what to call us Phoenixes, I guess. I'm going to be here until 9 o'clock tonight. Because we have a Zoom and I'm going to do it from here. And then I'm going to turn around and come to school at 6:30 in the morning tomorrow. That is where we start to run out of patience with you, as we are working very hard. Some of you need to work harder. Some of you need to work, period. Some of us don't do anything at home, and it's driving me crazy. This class isn't as big of an issue with that, but some of us, seriously, we're like, "Oh, I only do schoolwork at school. Whatever gets done, gets done." Yeah, that's a really bad mentality to be in. All right, all of these answers are recorded. So if you have more questions, I invite you to come work with me, like during all of those times that we provide you to work with your teachers. Beyond that, we need to review some stuff with scientific notation. This is on 824. So if 823 is done, turn it in. Honest truth, I don't know if I'll grade tonight or not, because I got a Zoom meeting, I got tutoring, I got a ton of stuff. And I'm keeping a couple kids after school because they're so far behind. And more so, I offered to them they can if they want to, and they made the right choice. They're going to stay. So get out 824 if you don't already have it out. That'll probably take the whole time that we have. So you may not need any more graph paper because we have 100, 101, and 102 on this paper. Now, we're doing, like, the examples from class. So, right here, you can do your work on your graph paper if you want. Right here, I want to flip my 5-minute timer and give you guys 5 minutes to try these problems. Like with your team, with your group, with a calculator, whatever. I want to give you 5 minutes to try these out. Yeah, on the first two, oh yeah, sorry, I did say calculator. Yeah, try it without.
All of them say that. I would say,
If we're trying to answer how many times heavier, what operation will we be doing?
Positive exponent.
How many times heavier we get from a division, right? To figure out a multiplication, we get it from a division.
So it'd be negative or negative exponent.
It depends on what your answer is. If your answer is a very small number, it might use a negative exponent.
okay, if we get rid of what's 4,500 divided by 2? I'm not using a calculator. I'm writing this down. 1,500. Oh my gosh. I did that using long division.
I will give you the rest of the 5 minutes. I'm laying down the timer. I promise. I'm going to give you 5 minutes on your own without me. But let's look at this real quick, because without a calculator, can anyone tell me the thought in their head for how to deal with this without a calculator? Like, I don't want to use the E word, but we want to try to make it as E word as possible, because it's not easy, but we want to make it easier. Nevin?
First off, I just ignored everything else, and I saw the number 45 and 3. So I figured out how many things go into
45 and 3 or 45 and 30?
45 and 3.
Okay, no, you're good. I'm just trying to hear you through the mask. So, okay, 45 and 3. So forget the decimal for a minute.
Yes. And I found out that 3 times 15 is 45.
So 45 divided by 3 would actually be 15.
So, here's what I did next. I moved the decimal place 1 space to the left.
Like
On
here?
15 on 3. You mean to the right. To the left. On the 3.
Okay.
I did, and then I added 1 to the exponent to make it 3. This happens on the
Okay. I know. I'm trying to follow. I already wrote that and I'm writing in pen, so.
Then I just found out the difference between the exponents, and I got 215 times 10.
I like it, but if I make this number 15, are we writing in scientific notation? I'd have to fix it then still, right? So what you did is correct, but if this first number's a 15, I still have to fix it. Can anyone tell me how I could get to a 1.5 here? Max?
Give me the thing.
We got to be quick, because I only got like 7 minutes left, so you can...
Well, then I did the whole thing where it was 4.5 times 10 times 10 times 10 and wrote that out with the giant fraction.
Okay.
And then I'm able to use the Big Daddy Uno to you find a lot of amusement in that. Don't you?
I find much amusement.
And I was able to use that to get 1.5 times 10, which is 630. And then I was able to do that to get 1,500 of how much have you removed.
So I love everything everyone's already said, and I'm sure, like, if I took all of what you guys have to say, I'm sure we can find a bunch more options. I want to go back to what Nevin said real quick. Guys, if we temporarily ignore a decimal, we're supposed to bring it back in at some point. So I love what Nevin did, was saying, well, just make this 45 divided by 3, which gets 15. But then, if I want actually what 4.5 divided by 3 is, I just bump a decimal back in because I had bumped it out. So I got to bump it back in. So really, this is 1.5. Or did anyone's brain say, oh, hey, this is 1.5 times 2, and this is 1.5 times 3? And kind of think of this as like 3 over 2.
I subtracted it.
We cannot subtract these numbers. It doesn't work like that.
Oh.
I know that this subtraction would also come out to be 1.5. That is a coincidence. That is not mathematically why. We have to do the division here. And without a calculator, there are many ways our brain could think through it. But this comes out to be 1.5 or 1.5 times, what would our times 10 be? 10 to the third. All right, giving you the rest of the time. Well, like 2 more minutes for you, and then we'll finish these problems together. Because my timer's going for you guys. What's up? So then that'd be, and then it turns into,
That's what I did in my head.
yeah, that's absolutely right.
And then the other thing is for this.
If you find yourself making noises right now, please check your immaturity level. Bring it down. Probably not, because it's Gus. He's like, no, I'm going to do what you're doing.
So then for this, does the E stand for scientific?
We're going to talk about that in a second. Yeah, dang it.
Yeah, I thought you meant like exponent or something.
Yeah, dang it. What does that E in our calculator mean? We talked about it one day when we got numbers way too big for our calculator to deal with it. Exponent of...
The numbers before it.
Yes, I'm pretty sure we talked about that. That was your number we were talking about.
All right. Up here, Anna just came up and asked, like, wait, would this work? Yeah. Another way that we could approach that first problem, if I change, like physically, actually change 4.5 into 45, the 10 to the 5th would become 10 to the 4th. We talked about this either yesterday or last week, I forget when. Then this division actually comes out to be 15. This actually comes out to be 10 to the 2nd. But then I have to fix it, right? Because this is not scientific. So I bump my decimal over, which takes my power up, and we end up with the same answer, 1.5 times 10 to the 3rd. Now the question on everybody's mind. What does this E in your calculator represent? It's the exponent of 10. So this actually means 1.44 times 10 to the 24th, which is a yada. This is 1.44 yadas.
Oh yeah, also the sugar one. 1.8 times 10 it's
Wait.
1.8
1.8 sextillions
sextillion. Oh yeah, it's not
molecules.
If it was negative, it'd be sextillion.
Wait, if
Yeah, if it was negative, it'd be with the THS on the end, right?
1.4 yada, isn't that the yada?
So,
Yeah.
if your calculator spits out an E, that means it's showing you scientific notation. But guys, can anyone guess why somebody programmed a calculator to do this? Go ahead. What? Okay, well, go sharpen your pencil first. Yeah, you saying call me is not going to make me call you. Patrick, I think you had your hand up. Why do you think they use the E instead of saying times 10 to the?
So you don't have to count 24 zeros. Because
Jordan?
because it's smaller.
It's a quicker, less amount of your screen.
Because mathematicians are lazy.
Literally, it takes up less of your calculator screen. That's why. Where are you going? I have 4 minutes. 3, technically. Get your paper back out. Guys, we're not going to start creeping out of class early. My class ends at 3:02. You better believe, especially if I'm wasting time waiting for people to talk, I'm going to milk every minute that I have with you. There is no wasted time, especially because we have a limited number of school days left. I'm starting to get stressed about it. I haven't been nervous about us making it through the entire textbook, but if I think about the fact that we have to try and finish it by mid-April, we only have 2 months left, not even, and we have spring break in there. We got to do work. This, when it tells me without using a calculator, here's my trick for solving numbers like this. If you literally didn't have a calculator, how do I say 1.75 the right way? 1 and 75 hundredths or 1 and 3/4. So I could write it as an improper fraction as 7/4. What about 6.01 the right way? 6 and 100ths. Or 601 over 100. We could multiply these and then we could reduce it. But now I'm trying to rush and this does not go well. Here's the thing. You multiply both of your coefficients with each other. So 1.75 will get multiplied by 6.01. And you multiply your tens with each other, but what happens with those powers? They add. So we're going to get something, and we'll pick this up tomorrow, times 10 to the 34. And then if this is not scientific, that first number, then we will fix it. Now you can go ahead and pack up. And I'm still getting you out of here early. This is different release than the morning class, guys. The morning class ends at 58. This class ends at 02. Right? I know when you're looking at the clock, you get in those habits. But 1A ends at 58. We end at 02.
Yeah, it's because it starts later, like the next
Add the two exponents.
Yep, because 10 to the 20th times 10 to the 14th would be like 20 tens and then another 14 tens. So in total, we have 34
I
tens.
wasn't sure. Okay.
And there's not even a name for that. If we have like times 10 to the 34th, well, there might be, but like if you look at that little table that I put over there, it's like the most extremes. It's like from the positive 24th all the way to the negative.
Okay.
It's wild. Yeah, you're welcome.